I started this class actually with asking you one question, which is how the VLAN actually would enhance the network security. Simply, actually, it was a topic what we discussed last class. That the VLAN, the virtual LAN, actually, it reunits entities from different geolocations separately and helps them to create a channel to communicate data in a hidden way from the other members from the same network. Let's say uh, the users that they share the same communication media. So this is one of the enhancements security-wise. VLAN actually it virtualizes the communication channel between the communicating nodes, however the distance is. So the virtualization concept, the uh, the behavior of unifying, let's say, not unifying, but in the sense of grouping the entities or the members, which are geographically segregated, very far from each other. So this is one of the security measurements. And specifically, the virtualization here is it's a security setup. It's not a concern of just communication because they would be actually communicating already, but the virtualization layer would be actually put into a consideration to eliminate any inferences. So actually, we continue from where we stopped. So behind of that, great. So that's where we were actually last, which is defining the virtualization concept. The virtualization actually it would be utilizing network peripherals, and amongst the definitions of the network peripherals, the workgroup switches and the core switches. If we define the workgroup switch, it's the switch that be utilized by the device straightforward, means to communicate devices. We may use a workgroup switch, one of the solutions, and to interrelate network trunks, subnet 1, subnet 2, subnet 3, and so on. To interrelate those network trunks, we may use a core switch. So from the solutions is the core switch to solve the issue of interconnecting network trunks or network subnets. So the core switch will interfere to interconnect them or interrelate them. Yep. To interrelate devices, we use a word from the solutions we use or that we can refer to is the workgroup switch. Yeah. And here actually for the concern of the virtualization specifically, the use of the particular switch is a must because the virtualization needs to have a punctual destination recognition. Means when we say that A has to send to B, it is punctual. Means A has to send to B. There's no doubt that it has to be successful. So selecting the appropriate switches for each task is a question behind succeeding to build a virtual LAN. We were talking about the services that also we might find over the computer networks, which is the audio video media. You might use the computer networks to communicate audio in real time, even to communicate video, maybe in the real time also. So what's the problem here? There is no problem actually. This is one of the considerations that this is one of the advantages of the IP networks, IP-based networks. What does mean IP networks? It means computer networks or computerized networks. There are benefits of benefits. One of the considerations to achieve such let's say success is to go through a convergence approach to succeed in securing and guaranteeing the service success. To make a phone call over the IP network, you might use devices that they are interconnected, and you may use the appropriate software to accomplish that. So technically, engineers have to, or let's say the concept here behind advised by the security experts is to go beyond a convergence in order to succeed. What is a convergence? Is to force, like the shock point, to force the users to communicate through a dedicated path to receive such a service. You have to pass through the computer number X, for example, to receive this service. This is a convergence. It's a must. So technically, you'll be directed to your communication actually will be actually redirected to a certain destination to pass through certain destination. There are advantages here. It's not a must that it's not that they are. Let's say the security experts here they are forcing you only for nothing. No, there are advantages behind also. Most of them the budget concern, which is the cost concern. The administration or the management is one of the very famous actually issues that have to be actually tackled, because to troubleshoot a path, it's better than troubleshooting a full network path or a mesh network based. So it's not the same scenario. So management is one of the benefits of the convergence. Implementing applications that run on a dedicated path that uses dedicated communication circuit, it's much more easier for development when you compare it to an application that cognitively chooses and selects the appropriate path for communication. It's not the same. Also, from the advantages is that the infrastructure will be limited. We will not need much more, let's say, peripherals and communication medias when we compare it to a dedicated path that has to be utilized. So one, it's not many infrastructure requirements. We will see actually an amelioration somehow. The policies and the politics for the setup of the well-being of this communication, let's say, framework, it will be actually minimized, because controlling one path is much more easier than controlling, let's say, a mesh-based network, because you have actually one path and the policies will be clear, first by first, or first in, first out, or whatever. So there will be actually reduced regulatory. Here we talk about policies and politics. And thus, since there are advantages, and those advantages from both sides, whether they are financial or that they are here administrative and managerial advances, so there will be actually a productivity incrementation. This is by consequence. Terminologies and the issues actually. Operating systems, computers, operating systems, they are equipped with dedicated software that helps in doing, or that helps in um, uh, fulfilling the communication of the voice over the network, or the IP network. Mainly we talk about the soft phones, which are actually the sort of telephones, but they are only software. responsible for dialing and connecting to the destinations and sharing voice, no more no less. What's the problem? The problem of the programmatic view is that they help in opening a port and a channel for a flow to be in out in lifetime, and since it's in lifetime, it's hard to filter by the security appliances, because if we do filter all the packets being sent and received in real time using those soft phones, there will be no real time communication, because any filtration to be done by the security appliance installed on that device, the sender or the receiver, needs time to filter, to finish the filtering. And this time causes the communication to be interrupted, and thus there will be no real-time communication. So this is a problematic. It has to run without filtering in order to achieve the real-time communication. And if it's done, if it's so, if it's the case, so it opens a fence. Actually, it opens a hole in the fence. Actually, those smartphones, soft phones, whatever. The second network vulnerability and second concern behind the, let's say, computerized network, and specifically talking about the voice over IP, the VoIP protocol itself, voice over IP protocol itself. So this protocol actually, it imposes an issue. It is actually the protocol responsible for doing or achieving or setting up the communication, the voice share, the voice communication over the computer network, the VoIP, voice over IP. And this VoIP presents an issue. It actually shares and helps parties to communicate, but it does not provide authentication mechanisms. It does not require authentication mechanisms. So if you are a user and you want to connect to another user using the VoIP, you will be immediately connected. You will not be required to authenticate yourself because of the VoIP only. Authentication will come to another through over another layer, but not over the VoIP layer. Yes, and for the same scenario, since we said that the filtering of the in-out flow using the VoIP protocol is not feasible in real time, the same way the encryption and decryption of the communicated media as voice in real time is not a feasible scenario, because encrypting and decrypting data, which is voiced, represented as voice in real time, requires time. It's a time-consuming process, and if it happens, it will cause no real-time communication. So the encryption and the decryption scenarios, they are not applicable for the real-time communications using the VoIP protocol or whatever. Why? Because of the time latency, the time latency that they cause. And this causes actually, if the issue here of the lack of encryption and lack of decryption, it causes a privacy exposure. Privacy means your data, the communicating party's data, being exposed. Who is the caller? Who is the receiver? What are the voices called, or whatever what are the media shared, and so on as voice. Everything is exposed. So any interceptor in between, any man in the middle attack in between, it can hear what is being communicated. Network acknowledgement. We know the DOS and we know the DDoS attacks actually. every single communication starts with a three handshake process, and this three handshake process is that the sender checks whether the receiver is available or not. And this matter of checking whether the receiver is available or not, it is called three handshake because there are three steps to happen: a synchronization from the sender to the receiver, and acknowledgement of synchronization from the receiver to the sender, and after an acknowledgement from the receiver from the sender to the receiver. Those three phases, they are messages to be sent, messages to be sent. The acknowledgement is synchronization second step. It causes actually the receiver to wait for the acknowledgement from the sender, which is a process, systematic process that causes time consuming. And because of this feature only, the flooding of the receiver, or the receiver causes a DOS attack. Causes the DOS attack. It can help in generating a DOS attack. Everything is there, DOS attack means, but no response. The spamming is not only related to emails and unwanted emails, but also to the unwanted phone calls. And especially, specifically, we talk about the phone calls over the IP networks, because they might spread unwanted advertisements or unwanted messages or unwanted medias or whatever. Spams. So, but here the spams, they are the spams over the computer networks. The computer network, they actually yes, do the let's say take care of the voice over IP communications. A security approach via which we see an enhancement to the computer networks is the adoption of the demilitarized zone, DMZ zone. This demilitarized zone is an area where army would not access, demilitarized. But here we say that this is a demilitarized zone. Why? Because there will be no security appliances, no antivirus, no firewall, no filters, whatever the filter type is. Demilitarized zone. Everything runs without any security checkup by any security appliance. Technically and furtherly here, when we talk about computer networks, this is a graph that demonstrates or shows us the use of the demilitarized zone. We have our network, for example, this is the University of Israel campus network, for example, and everything comes from the internet, or everything goes to the internet. This is the path. At the entry of the network, at the entry filter, we may say, of the network, or yes, of the regular network, there might be the installation, there might be actually an installation of a demilitarized zone, which is a small network that mimics the real network services. This mimicking, this demilitarized zone, which mimics the real network, it has similar services to the services available inside the network. When the attacker gets in to this demilitarized zone, it would think that this is the real network because the services are there. So it would attack its victim, which is here in this demilitarized zone. And here there is no victims because all of them, they are set to track and trap all the vendors and the accessed people to this zone. Anybody access this demilitarized zone, he is an attacker. Immediately will be caught. DMZ, demilitarized zone. Demilitarized zones, they are actually scenarios how to apply the demilitarized zone. See the differences in between those two graphs. For the first one, actually, simply at the entry of the network, we said here there is a firewall, there is a filter, and on top of which there will be a link to guide the users to the DMZ zone. Here, one filter only, which is one firewall in this example. But we can see a two firewall based DMZ zone. Means anybody tries to access this network by must has to access the DMZ because there is no link directly set. Here, security experts and the owners of this network, they might access directly without any relation with the DMZ zone. But here in the two firewalls based scenario, all the users, whatever they are, the owners or the administrators, all of them, they have to pass through in the network area only through the DMZ. So they have to enter the DMZ, then access it, then filter again to access the resources, the computer in question, the computer network in question. DMZ, demilitarized zone, remember the name. Any questions at this level, please? Any questions you raised from here before we keep going on? Okay, this is great. We keep going on. We said at the beginning as the objectives of this chapter is that we are going to learn technologies that enhance to the way how the network behaves in order to secure the media, communicate the packets and the French to communicate in the network layer. From the technologies available is that to hide the identity or to match it with an alias. It means this is my IP address, this is the computer I'm using address. But I'm going to hide. I'm going to use the technology to match my IP address with a fake one for a security reason. Amongst the technologies is the NAT, network address translation. It's a scenario, literally speaking here, it would hide your IP address and matches it with an alias, which is another IP address. So the attacks, if they try to attack you from the public networks, they would see the hidden IP address. They would not see your own IP address or the specific, the computer's specific IP address. Network address translation. The translation here is to match the real IP address with a fake IP address. For this concern only, there are exceptions. There are exceptions. The NAT will not work with the non-used IP addresses. The NAT will not actually force okay. Exactly what we were discussing. The NAT, it's a concern of hiding the real IP address and matching it with a fake one. It's not a fake, but it's an alias. So any people, any party from the external world, they will see your alias, your fake IP address, not the real one. So if they try to attack this IP address, they will do, but they will not find any destination. This IP address does not have any representations of the network. This table here that matches the original IP address with the alias, which is another IP address, is available inside the network, let's say, devices, which is to be utilized by those network devices. It will not be actually shared with the people in the public network. No. Yeah. Like the same way, actually, as we talked about the network address translation, another approach via which we enhance the security, which is the port address translation. Any communication between two parties inside a network, there have to be actually an address and there have to be a service number, which is the port here. Actually, we mean by it, we talk about the port, the service number. For example, I give you the example. If you are willing to open the internet, what you will do? You will just type www.internet.com, for example. This internet.com, it is a service, and to run out your request, to run out from your computer, there have to be actually a service number. Here we talk about the port. For example, you are going to use the internet, so the internet is to be utilized over the browser, requests, and your requests have to be carrying an address, specific address to go to. In addition to that, there have to be a service number, which is specifying the web, the www environment, which is 8080. So here we are going to hide those numbers, those IP, not IP, those inner numbers. Port address translation, it's a concern of sweeping and changing and matching the real, let's say, ports, service ports, with a fake one, let's say, with a fake one. It's an alias also. It's an alias. Another security concern, which is the network access control, the NAC. This is sort of an access control, yes, but it is the network layer, over the network layer. This access control here to allow who to use, what to use, when to use also. But on top of the list of services, whatever. So the access control here, it's a filter to install or to use from within the device in question. Devices will be controlled and not being allowed access to the network unless they are authenticated and unless they are given the access, the right to access those services or the service in question. Network access control. If something is not matched, so that it will be actually eliminated. Here actually, since we said that there is a filtering and this network access control is a sort of controlling who is going to access and who is not, so it's a matter of filtering. So it's a security approach to avoid, that can be utilized to avoid the spread of the issue once happened. Okay, then the utilization of those services and the adoption and the running of those services requires an automated system to do so. So when we talk about the creation, for example, of the VLAN, virtual LAN, which is to reunit devices which are geographically separated, how it would do so that? So it has to be done through a systematic approach because the number of the requests, it is not a small number, it's not just tens, it is thousands and millions of numbers. So The automation of such a process, of any of the processes we discussed, it is a must. It is something to be considered. And here, for the example you are taking, is the DHCP protocol. It's a protocol responsible for sharing resources amongst the users of the net, IP addresses, MAC addresses, those filters to check and to scan. So all of the activities will be done automatically using what? Using the DHCP server. Or the DHCP, actually, it's a protocol. We can attack the computer itself to redirect the communication into a specific destination. We can do actually a nerve poisoning approach, via which we infect the device in question. Yes. There are technologies that can be specifically dedicated to such services. All the services we defined so far, they are either to be customized by the let's say the security, the network security, or the whatever is responsible for, or you can use dedicated devices. Just they use that they provide whatever you need specifically. Those are examples of vendors that they do work on this field since long time. So here actually it's a matter of reading only. It's not a big secret. You just refer to those providers, those procurers, those manufacturers. What we are explaining now in our actually course, it is related to Microsoft fields only. So if you hear your name, just say yes, please. Any questions before?